Well, howdy there, Internet students. It's Mr. Hermanson again. We're going to start lesson 2.2 today. Ratios and proportions. We've kind of been leading up to this in our previous work, but we're going to continue that now. So if you graph a proportional relationship, you will see a graph like this one here. You'll see a straight line that starts at 0, 0. And that's because whatever you're mixing, like if you're mixing peanuts and raisins and you have 0 mix, you're going to have 0 of both. So that little spot right there, that means that's called the origin, and it's the point 0, 0 on a graph. On a number line, the origin is just 0 because you only have one dimension. But on a two-dimensional graph like this one, the origin is right in the corner there at the point 0, 0. Okay, so on this graph, now make sure you're paying attention to this and you'll always understand graphs better. There's a point right here where we call that point 6, 4. And what that's telling you is that this 6, the first number, is on the x-axis. And that represents raisins. So, so that's saying that we have 6 cups of raisins. And then the other spot, that point that makes that point, is on the y-axis, the number 4, which is cups of peanuts. And so this is representing a trail mix with 6 cups of raisins and 4 cups of peanuts. So 10 cups altogether. Okay. Go ahead, you guys, pick 2 other points on the graph and write their coordinates here. I just want to make sure you guys can write coordinates correctly. Go ahead and do that. So here are some possible points you put down. You make sure you put the x-axis number first. Now, notice there'd be a point there even though it doesn't show up, and that point would be 9, 6. So, so I added that also. So what are the peanut to raisin ratios of these 3 points? Peanuts are on the y-axis, so that would be this number. And then on the x-axis, it's 6, so the ratio for that point is 4, 6. For 0.2 is, they're talking about this one. That one is 2, 3. And for 0.3, that would be 0, 0. Or 9, 6. Okay, so let's get rid of the 0, 0 because that one always messes us up because it doesn't really represent a mix. It represents no mix. But if you look closely at all these ratios, you'll notice they all can simplify to the ratio 2/3. So they are equivalent ratios. And if you have a relationship with a bunch of equivalent ratios, we call that a proportional relationship. Okay, so this is just information about that. All right, now there's a couple ways you can test. One way is to do cross products, because if it's proportional, then the cross product should be equal. That's what this is showing. So you would do 9 times 4, which is 36, and then 6 times 6, which is 36. And if you get the same number, then it's proportional. The other thing you could do is simplify the fractions down to lowest terms. So 9, 6, you can divide both those by 3, and that simplifies it to 3/2. 6/4, you can divide both those by 2, and that simplifies that to 3/2. Since they both simplify to the same number, they are proportional. Okay. You could do this way where you hide a term and then compare. And so if you hide one of the terms, then do the cross product, so the other do 9 times 4, and then you divide that by the other number, 6. That's 36 divided by 6. you should get the number that you hid, which is 6. And that works. The other thing is just change them to decimals or percents if you like. But changing them to decimals works really good. And if you get the same decimal, you have the same fraction, which means you have a proportional relationship. All right, so let's do some problems and see if it is proportional. Okay, Brian says that he created mixture B by adding one red container and one white container to mixture A. So he added one to each of those. And then for mixture C, he did the same thing again. He just added one more again from the original mixture. Okay, and he thinks that because he added the same amount of red and white to each container, they're proportional. Okay, so let's see if he's right. Right now, you're probably not sure. So for mixture A, the ratio of red to white would be 2 to 1. For mixture B would be 3 to 2. And for mixture C would be 4 to 3. Now let's just check and see if those ratios are the same. This one we get 2 over 1. 2 divided by 1 is, I'm just going to do the decimal thing here. That'd be cool. So for A, we have to do 2 divided by 1, which is 2. For B, we have to do 3 divided by 2, which is 1.5. And for C, we have to do 4 divided by 3, which is 1.3, and you'll notice the 3 keeps repeating. Now, if it was proportional, then those numbers should all be the same, and they're not. So we're going to say, sorry, Brian, you are not correct here. You can't add the same amount to a ratio and expect it to come out the same. Okay. Another suggestion, you guys are good at percent, so if you want to find the percent of, say, red in each mix, let's try that here, you guys. I'll move it back up here. The percent of red in this mix is 2/3, and remember to change that to a percent, you just do this. I like to do the 2 divided by 3 first, which is 0.66, and then just move the decimal over 2 places, because that's what happens when you multiply by 100. So this one's 66% about, I'm rounding that. This one here is 3 reds out of 5 total. Now 5 times 20 is 100, 3 times 20 is 60, so that one's 60%. We can already see that we're not going to have the same percent of red in each mixture, so it's not going to be proportional. All right. So check this pattern out. Kenyon created this pattern. So I'm going to give you a second just to look at those patterns and describe what's going on with the number of green and yellow tiles from one stage to the next. Just go ahead and write something down. Don't worry if you get it wrong. So as I was analyzing this, I noticed that every time we go up a stage, we get 1 more green and we get 2 more yellows. You can look closely, pause if you haven't figured that out, but it should make sense to you. So we're going to, for the stages shown, we want to know if the number of green tiles is proportional to the number of yellow tiles. In the first one, we have 8 yellow, 1 green. So let's put 1 over 8 for that one. Stage 2, we have 2 greens and 10 yellow. Then we have 3 greens and 12 yellow. Then we have 4 greens and 14 yellow. I'm going to say this is not proportional. Look closely at those fractions and maybe you can decide how you know that. But 1/8 is like 0.125. 2/10 is like 0.2, 3/12 is like 0.25, and 4/14 is like 0.28, something like that. Anyway, they're not the same dimensions, okay? So we're going to try and change this and make this proportional. Okay. And here's my suggestion. If you multiply by the same thing every time, it'll stay proportional. And that makes sense because think about how you change fractions. Like if you do times 5 on top times 5 on bottom, you're going to get 10 over 15, which simplifies to 2/3 because the way you would get it back there is divide by 5, right? So if you do multiply the same thing to both numbers, it will remain proportional. So let's say I want one more green in stage 2. So I'm going to double my greens. I'm not sure how I'm going to, I'm just going to put GG for 2 greens. How's that? So if I double the yellows also, right now I have 8 yellows. If I go to 16 yellows somehow, then it will remain proportional. So let's just set it up this way so we're not trying to draw these pictures all the time. Let's say 2 green and 2 green and 8 yellows times 2 is 16 yellow. Okay, so right now the ratio is 1 green to 8 yellow. And stage 2, if we have 2 green and 16 yellow, 2/16, that will also equal 1/8 if you simplify that. Just divide those by 2, right? In stage 3, let's say we have one more green, we go to 3 green. Well, we need to multiply 8 times 3 to get the number of yellows, which is 24. So 3 over 24, if you divide both those by 3, you get 1 over 8. So we're still keeping with the same ratio. All right. So we can solve some problems using this idea of keeping the same ratio, keeping things proportional. Stores are able to make a profit by buying in bulk. They are charged less per item because they buy a whole bunch of them. So we're going to compare these two situations and see if they're proportional or not. Sometimes you may not get a better deal. So if we have 100 t-shirts for $28, you guys, a thing that we can use here is called a unit rate. So the price per unit, which is like finding the decimal for a ratio. So let's do that here. So $28 divided by 100. So remember, this is a divide sign, equals 0.28. And then I'm going to do my 3,000 t-shirts, $1,280. So I'm going to do $1,280. Make sure you divide them the same way. Divide it by 3,000. 1,200. No, 12,180 divided by 3,000 equals 4.06. Well, I think this is a lot better deal here. The 100 t-shirts for $28. Those are 28 cents a piece, less than $1 each, and these are like $4 each in that batch. So why don't you try the next one? Do the dollars on top and the number of items on the bottom when you divide them. That way you're figuring out how much it costs per item. Give it a shot. You should notice that in both those ratios you get the same amount. So this is a proportional deal here. All right. So go ahead and try the next one, see if you think it's proportional. I'm thinking not on that one. When you buy the 800 packs, you get them for 12 cents each. When you buy the 36, you have to pay 20 cents a pack. Okay, so Describe two ways to determine whether a relationship is proportional. Now remember, there were many ways, so go ahead and see if you could come up with two ways, and I'm going to write down what I think are the easiest way. All right, so here's the two ways I like the best. Change all the ratios to decimals, see if you get the same decimals, or use cross products. Just multiply the numbers kitty corner from each other and see if you get the same numbers. All right, so I think you're ready to try a little homework, see if you're catching on to this, and we'll talk to you soon.